Welcome to Data Analysis Made Easy with Microsoft Power Tools. Yes, that's right, Dame with MPT number 5. And in this video, we got to talk about M-code. That's the function-based case-sensitive coding language inside of Power Query. Now, as we've done with all the other functional language we learned, we always ask, hey, why do we use this particular language? Well, with M-code, it's easy. M-code can get, meaning import or connect to data, transform the data, and then load it to some place like the data model in Power BI Desktop or Excel, a pivot table cache, or the worksheet. And it can do things that the other function-based languages just can't do. It can hold a complete column of files and then combine those files. It can connect using functions like SQL.Database directly to a database. So M-code, when we want to get, transform, and load data. Now, it is a function-based case-sensitive language. Well, there's a function right there, Excel.CurrectWorkbook. Here's another function, Table.transformColumnTypes. And notice they are case-sensitive. There are capital and lowercase. And if you don't spell it right, it doesn't work. Now, Power Query and M-code are in Excel. This is the editor in Excel. They're also in Power BI Desktop. And they're in online Power BI data flow. Now, the fundamentals of M-code are exactly the same in all three Power Queries. There are a few different data connector functions, but everything we learn is the same in all three Power Queries. Now, some of the buttons are in different places. For example, here's Data Flow Query Advanced Editor. There's Manage Connections instead of Data Source Settings, and there's Get Data. Power BI Desktop Home Query, well, there's Advanced Editor, so it's in the same place as Data Flow. There's Data Source Settings, and there's New Sources. In Excel Power Query, Home Query, and there's Advanced Editor. Data Source Settings is way over here, and we have a new source here. Now, these are the three files that you can download. You can either work in Excel or Power BI Desktop. If you want to work in Data Flow, import the tables from the Excel file. And of course, there's PDF notes. Now, these PDF notes don't have a lot of step-by-step instructions like some of the other notes in this class, but it does have really good notes about the parts of M-code that we're going to study. Now, I'm on the sheet Tables, and your worksheet will have many more tables, and you will have many more start queries. I've started a bunch of queries, and then we'll just use these queries to learn about M-code. Now, the keyboard to open up the editor in Excel is Alt F12. I don't know the keyboard or even if there is one in the other tools. This is the Power Query editor. On the left, we'll always have a list of all of our queries. When you open your start file, there'll be a lot more queries. I can select a particular query. On the right, here's Query Settings. That's the name of the query. Here are the applied steps. We have 2 steps. And one of the beautiful things about Power Query, of course, is whether you use the user interface or create your own steps, you can go back and forth between the steps, look at them, edit them if you need to. Even after you load and create reports, you can come back and change things as necessary. Now, when learning M-code, the first thing we need to learn about is what is an expression. But actually, you have to know what an M-code value is before you can define what an expression is. Now, before I even do those two things, I just want to show you where we can edit M-code. The first place is in applied steps, and we'll see how to do that in just a moment. The second place is up in the formula bar, and the third place is the advanced editor. Now, I'm going to cheat here also. We need to know what an expression and values are, but I'm going to sort of define what the let expression does, because much of what we do in Power Query goes through the let expression. Now, the let expression allows you to define steps or variables. For example, we're going to define source. Then we put an equal sign. Then we put whatever the M code is. In this case, it was the Excel.Workbook function going and getting a particular table. So let allowed us to do that. Source is equal to this, and source is going to deliver a table value, and we can use it throughout the let expression. You cannot use it outside the let expression. Then, since we have more than one step, we type a comma, and that comma tells Power Query, hey, I want you to deliver the result of source, which of course is a table without data types. And if we look down here, there's step 1. It delivered a table without data types. Then we define a new variable. Add data types as a new variable or step. It's equal to Table.transform_column names. Now, one thing you'll notice about M code is Microsoft named the functions really smartly. It's really easy to understand what this function does. Now, importantly, what is it doing? It's acting on the previous step. And so almost always the following step uses whatever the identifier is from the previous step. And most of the time, it occurs right in the first argument of the function we're using. So there it is, add data types. There's the function. But look at this. There's no comma. And that's because when you put a no comma, everything after this is what the query is going to deliver. If we look over here, add data types is now delivering a table with data types. Source was an intermediate step. Add data types acted on that, created this table with data types. And since that's the output we want for the query, we don't put a comma. And then you put in and list what the output for the query should be. Now, almost always, the last step is going to be the output for the query. But as we will see, there are some exceptions. So there's a let, and sure enough, it is an expression. But let's click Done. And in the PDF notes on page 6, there it is. Expression is any M code that results in a value. Right, so really you have to start with what are Power Query values. Because this is, in essence, the base of most of what we do. We create some expression, and it delivers a value. Now, examples of expressions, well, we could have Table.Column names. That extracts column names from a table. We could have a list, a number, a query step within an expression. So in the let expression we just saw, there were 2 query steps. Both of those were expressions. And the full let expression itself, because it delivers a Power Query value, is an expression. Now, finally, we get to talk about the 15 types of M code values. Now, a null value is the absence of data. And when you enter it in M code, you do it in all lowercase. Logical, that's true or false. Hey, same here, lowercase. Text, when we enter it, just like in Excel and DAX, we put it in double quotes. A number, notice the definition is used for numeric and arithmetic operations. Here are some examples. And we'll see in a moment that if you have a number value and you apply data types like decimal or whole number, the value underneath is still a number value. Time, just like in Excel, it's a serial number from 0 to 1. And we're going to have to use what's called an intrinsic function if we want to hard code time into M code. Date, a serial number, and it's not from January 1st, 1900. It's from 1/1 of the year 1. So historians are happy about Power Query because we can have historical dates before January 1990. That's how you enter a date with an intrinsic function. Datetime, there's the intrinsic function. Datetimezone, there's the function. And duration is something different that's not in the worksheet or DAX. In Excel or DAX, if you take end date minus start date, you get number of days, not a duration. A duration is an amount of time. We also have M code values that contain many other M code values. A table, well, it can hold lots of numbers or text or logical. And if we want to hard code a table in, we can use a syntax like this. A record, there's the syntax for a record. If you extract a row from a table, you actually get a record. A list, we're allowed to type in curly brackets a sequence of items. It's not like array syntax in the Excel worksheet. There's only commas to separate the sequence of values. And if you extract a column from a table, you'll get a list. Binary, that represents things like files, Excel files, CSV, or picture files. Remember, we can have a column of binary Excel files. A function, we're allowed to define our own function. And we'll see how to create reusable functions, but also functions specific to a certain formula. And then type. Type is data type. Now, there's 16 different data types. And data types are different than values. As I mentioned earlier, if you take decimal, currency, in Power BI, it's called fixed. That just means you have up to 4 decimals. Here, it's up to 15. Or you take a whole number or a percentage. These are data types, but underneath all of those is the single value number. And we'll see some examples of how values and data types interact. Now, if we scroll way down, here's a list of all the operators in M code. But here's the crazy thing. In Excel and DAX, you can take a date and add a number and get a future date. So mixing a date value with a number value is no problem in Excel and DAX. But in M code, you can't do that. You can take a date because it's a date value and subtract a date value because it's a date value. And when you do that, you actually get a duration. But you can't add a number to date. Now, there are a few exceptions. When you want to combine date and time to get a date time value, you actually join them using the ampersand. In the worksheet in DAX, you add them. Another exception is the null value. Well, if you add or subtract or do any operation with null and anything else, you just end up with null. So null can interact with other values, but you just always get null. And the other main exception is duration. If you want to add 10 days to date, you say date plus duration. There's also functions that we'll see where we put in a date and 10 days, and it gives us the future date. But you want to remember a big difference in M code is that operation between different value types is in general not allowed. And actually, in the notes I have for each data type, I have a table of what operations are allowed. Now, taking a look at our let expression again, let's identify a number of expressions. Well, remember, a query step can be an expression. So Excel.CurrectWorkbook and the rest of this M code, which looks up this table, that's an expression that delivers an M code value, a table value. We know that the second query step, Table.transformColumnTypes, also delivers an M code table. But within each function and within each argument in each function, there are other M code values. Right here, this is a text M code value. It's delivering the word date so that Table.transformColumnTypes knows what column to add the data type to. And this is a type M code value, saying the specific type of data type to apply. And then look at this. This is a list. And lists are very convenient because they allow us to enter multiple items into a single location. In fact, this is a list within a list. And for each position in the outer list, it needs 2 things to apply a data type, the name of the column and the data type. All right, let's add a new line of code and see what happens up here in Advanced Editor and the formula bar and in Applied Steps. Now, let's change the data type. I don't want date time, so I'm going to click the dropdown. Actually, let's open up the formula bar and watch the formula change in real time. Click the data type icon. Come down to date. It's polite. It says, do you want to replace the current? Because the previous step was adding a data type. And sure enough, just like that, it updated. Nothing changed here, but if we go up to Advanced Editor, of course, it's reflected there. Click Done. Now, let's add a new step. I want to group by and get a unique list of day type, and then add to get total sales. This is like sum ifs or count ifs or a pivot table. Right-click. Group by the column we want a unique list from, well, day type. We'll call this total sales. And the operation, there's a limited number of aggregate calculations in Group By in Power Query. But there's an easy way to get around that. So we're going to sum on the sales column. And when I click OK, now we have a third step, and it's delivering an M code table value with a unique list and an aggregate sum for each unique item. If we look up to the formula bar, there's Table.Group. It's acting on the previous step to make some transformation. Hey, there's the name of the column that it used to get a unique list. And notice it's in list syntax. Well, what is the definition of a list? A sequence of items. Anytime you see an automatic feature enter something as a list, you know that more than one item is possible. And sure enough, in grouping, you can have multiple columns, multiple conditions on the row. And then this clever list within a list again, well, we only have one aggregate calculation. And because three things are required to create this column, the name of the column, the formula that's calculated in each row, and the data type, that's all required. So the list comes to the rescue. I need three things in the first position in the outer list. If, as we will later, and we already had earlier in the class, when we have more aggregate calculations, comma, and then another list. Now notice the step is named Grouped Rows. Let's go up to Advanced Editor. And sure enough, now in our let expression, we have 3 lines. For each line, we have what's called an identifier, equal sign. There's the expression which delivers a table, comma, because this is not the last line. There's a new identifier. But this line refers, using the identifier, back to the previous step, comma, because this isn't the last line. There's the new identifier. It's referring to the identifier from the previous step. There's no comma. So following that, we have in. Following in, that's the query output. In our case, we want group rows as the query output. But what in the world is that double quote, and pound doing? How come I don't have that syntax up here? Well, for identifiers, whether it's a query step, a variable, or a query name, if you use spaces, you have to use that syntax. And the reason you can't just use double quotes is because that's the M code syntax for text. So if you use double quotes, M code interprets it as text. So the rule is don't use spaces in identifiers. It's just messy, and it makes code hard to read. Now, instead of changing it in 2 places up here, I'm going to click Done. This is a great time to use applied steps to edit the M code. F2, something like Group By, Day Type, and Enter. And now when I go up to Advanced Editor, the M code is much neater, much easier to read. Now I want to add a new aggregation to Table.Group, and I don't want to type it up here, so let's click Done. I want to come over to Applied Steps. Notice only one of the steps has a gear icon. That gear icon allows you to click, open up the dialog box, and then change the step. We want Advanced, Add Aggregation. We'll call this Standard Deviation. I'm hoping it's in the drop-down, but nope, the aggregate functions available in Group By and Power Query are very limited. No problem. We're going to select Sum. We're going to use it as a placeholder, so Group By will write most of the M code for us. We want a sum on sales. Now I click OK. There's the sum. That's not what I want. This is definitely an example of where I like to use the formula bar. I'm simply going to double-click Sum, Standard Deviation. I see it, Tab, but I want you to notice here that gear icon. Watch what happens when I enter. I'm going to enter the formula using the check. So when I click Check, that gear icon goes away because we put something in the formula that's not in the dialog box. Now, Table.Group actually has some other arguments that are quite useful. We'll see them later on. But anytime we add anything that's not in the dialog box, that gear icon goes away. All right, so Advanced Editor. Now, there's our finished let expression inside the day types query. Now, when we're typing out M code, words like let, in, type, date, each, text, number, and other keywords like and, not, and or, those keywords are reserved. Now, if you use one of these keywords as an identifier, you get that messy double quotes and pound. But you can trick it. If you want a date, instead of all lowercase, you just start it with uppercase D. And because M code is case sensitive, that would work. Now, I want to edit up here in the advanced editor, I don't want yodel sales, I want total sales. And sometimes if you want to read the code up in the advanced editor, instead of Alt-Enter like we use in Excel, you use Shift-Enter. And I'm going to use the Tab key, Table.Group. I'm going to leave the previous step and the column to group, backspace, Shift-Enter, and Tab. Let's bring the second aggregate calculation down, Shift-Enter. And over here in the PDF notes on page 12 and 13, there's some let expression notes. And here is a little diagram about the syntax for let. Lowercase let always starts it. The identifier, if it doesn't have spaces, you just type it out. Equals some expression, comma. If you have spaces, you have to use that syntax. Equals expression, comma. At the end, we have the third identifier, the expression, and then no comma and in. Everything after in is the output. Now, usually, the output is the last step, especially if you use the user interface. But sometimes that's not the case. For example, we'll use let and in to create variables inside of formulas. And we'll define a bunch of variables and then just create some formula we want that uses those variables. Also, you can add comments to help explain what a particular step does. You can use / twice. As long as you don't hit a hard return, you can just keep typing. If you use hard returns, then you have to use / asterisk and type as many lines as you want, and then close it off with asterisk /. Now, starting on page 13 in our notes, I have a whole section on all the different M code values and the operators for the different values. Now, what we want to do is go through each value. We're actually going to create a new query, type out the value, look at the operators, and then see how to use the values in formulas. Now, let's create a blank query in Excel, Home, New Query, New Source, Other Sources, Blank Query. In Power BI Desktop, New Query, drop-down, New Source, and there's Blank Query. In your Power BI workspace, New Data Flow. We want to click Add New Table, and they're going to try and make it hard to start a blank query. View More. Look at all these connectors, and right down at the bottom, there it is. All right, I named my query M code values. And what we want to do is add a step for each value, and I want to name each step. I can't rename source here in applied steps, so I'm going to add a new step, clicking F of X. And I'm going to highlight that, and we'll start with the first value, null. Now, watch what happens if I hit Enter and try to enter this. That IntelliSense is not being polite. That's not what I wanted. So null, that is why oftentimes in Power Query, I use the check to enter it. And there we get a null and a null here. Now I want to name the step, and I'm going to try and name it null. That's a keyword. If I go up to Advanced Editor, oh yeah, I don't want that. Close. I want to F2 and rename it with capital N. And now, sure enough, that's allowed because M code is case sensitive. Now let's add a new step. It pretty much doesn't matter what operator you use. That's why there's not an operator table in the notes. Because when you do some operation, like add 5, the answer is always null. I will let you name all of these. As you go along, I'm going to name them something smart, null plus 5. All right, the next M code value is logical, also called Boolean. And we have to enter true or false as lowercase letters. When I click the check mark, what? The trues are in capital letters? But if you go up to Advanced Editor, in the M code, it's got to be lowercase. Now let's see if we can do something that we are able to do in Excel. If we add true plus false in Excel, we get an answer of 1. But here it says, nope, you can't apply that operator. That's why having these notes can be helpful to explain the trouble. Yep, the plus is not here. The next value we're going to look at is text. And you can certainly do comparative operators. It'll work off the alphabet. You can join and coalesce, which is an operator we will see later. It just takes the first non-null. Now I'm going to leave the errors there as a trail. Let's F of X, and we want to add some text. double quotes, and I'll type quad, check mark. In the formula bar, we see it without the double quotes. But over in the actual M code, it's got to be in double quotes. Now let's try a new formula. 5 plus a text 5. Now in Excel, the plus operator will coerce this into a 5 so we'd get the answer 10. But not over here. We're not allowed to apply that operator. Yep, I don't see the plus operator there. Now the next M code value we want to talk about are number values. These are all number values. If we have this number value and we apply a percentage data type, it's still a number value. If we apply decimal data type, this is still a number value. If we apply fixed data type over in Power BI or currency in Excel, only 4 decimals are allowed, but it's still a number value. Apply whole number data type, it's still a number value. And why that's important is because it is the underlying M code value that determines what operators are allowed. So even if you have percentage data type on one column and decimal data type on the other, you're still allowed to multiply them because they're both number values. Now down here, a lot more operators for numbers. And as we mentioned, duration is one of the exceptions. It is a value type that can mix with other value types. For example, we might have a duration of 8 hours, and we want to multiply it by 5 to get total hours worked for the week. All right, we're going to keep that error as a trail. Click F of X. And I just want to type a number here. I'll type 43 and enter. We see 43 in the formula bar here in preview, and it's the same up in advanced editor. Now let's go over to number data types and Colaesce. Now, I've already loaded this to the sheet called result. Notice we have decimals over here, and there's a sum function pointing to the output. What happens if we change this to whole number? I'm going to replace the current. What actually happens is in this step right here, the decimals are removed. Back in the original source, the decimals are still there. So I'm going to apply whole number to both. And we haven't loaded the M code, so be sure to close and load to. In Power BI and Data Flow, right-click, uncheck Enable Load. We want here in Excel only create a connection. And bam, just like that, of course, the output is now looking at whole numbers. But what if you made a mistake? No problem. The change was made here. The source still has the original decimals. So we can absolutely go back. I want decimals for both of these. They're back. Close and load. And the decimals are back. We have our decimals back, and we would like to calculate sales minus discount to get net sales. If we're in the Excel worksheet or DAX, null would be an empty cell. And an empty cell is converted to a 0 in those functional languages. But over here, we know we have a problem with a null value and any other value. Now, I want to look at 2 different ways to calculate net sales. Sales minus discount. We'll go up to Add Column, Custom Column. And after the equal sign, I'm going to double-click Sales, and then minus Discount. Now, when I click OK, we're going to get the null values. But we can build a conditional statement that says, if discount is null, then just give me sales. Now, there is a conditional add column feature here, but we haven't looked at the if, so we're going to edit this with the gear icon. Now, we have not looked at the if expression, but let's take a look. And guess what? When we type if, it's not uppercase like Excel and DAX. If discount is equal to, and we type our null value, we don't use commas, then please give me just sales. No comma, it's else. We want to make the calculation, sales minus discount. And that's our if then else statement. Click OK, and that does the trick. However, when you're dealing with nulls, there's an easier way. We can use the Colaesce operator. From left to right, if you use Colaesce, it'll take the first non-null value. A custom column. We'll make our calculation, sales minus discount. But if that comes out null, we use 2 question marks. That's the coalesce operator. Then we want just the sales. And that amazing little simple formula from left to right takes the first non-null. So when this is not null, it just delivers that. But if it is, whoop, it goes over to sales. Now this assumes that we're always going to have sales and no nulls in the sales column, but that's a safe assumption. Click OK. And there you go. Much easier formula using coalesce. Now these 2 columns do not have data types. And instead of clicking the icon and adding another step, let's look at the Table.AddColumn function. We click at the end and type a comma. That means it's going to show us the argument screen tip here. The first argument is table as table. That's the previous step. Second argument, new column name. We have that. There's an argument that requires a function. Now you can put a custom function here, as we'll learn later in this video, or you use the keyword each. So each, and then we have our formula. You can think of each as saying, hey, I'm going to run this formula in each row. But there's a third argument, column type. So I'm going to type the keyword type followed by, well, I want decimal, and the data type for that is number. You can see it pop up in green, so you know you got it right. Click the check mark. Look at that. Without adding an extra step, bam, we have our decimal number format. Now the next M code value we want to look at is time. I'm going to add a new step, and we'll use an intrinsic function. Starts with pound, lowercase time, open parentheses. And it needs hour, minute, and seconds. I want 8:10 a.m., 8, 10, 0. And when I click the check mark, I've hard-coded 8:10 a.m. into a formula. Now, both for times and dates, most of the time we get the raw data in a column, and then we're doing calculations. But sometimes we need to enter it in as a hard-coded value. And even though it showed us the time in the formula bar in preview, there's the intrinsic function. Now, I have time, and I just want to add 8 hours, so 8 divided by 24. But those are different values. Number and time, it tells us right here, can't use that operator. If we want to add 8 hours and hard-code it into the formula, that's where we use duration. We use a pound, duration, open parentheses. And this function has 4 arguments. Day, we have 0. Hours, minutes, and seconds. Now when I click the check mark, 8:10 a.m. plus 8 hours is 4:10 p.m. If we want to do date, intrinsic function date, and we do the year first, comma, then month, then day. When I click the check mark, there's the date. And sure enough, up in the M code, we have that intrinsic function. In Excel and DAX, we can just add a number. But if I check, of course, that's not allowed. In the PDF notes on page 18, here are the operators defined between 2 dates. And yes, date works with duration. And one instance, it works with time if you use the ampersand to merge into Datetime. Well, if we want to add days, we just use duration. 5 days, comma, no hours, minutes, or seconds. Now when I click the check mark, sure enough, that's 5 days ahead. Well, there's another way we can add 5 days. There's all sorts of amazing date functions. We can add days, months, quarters, weeks, and so on. .AddDays. And so we could have a column of dates, comma, and we want to add a set 30 days to get the due date. And just like that, using Date.AddDays, there's our due date. Now, we definitely can take 2 date values and use an operation. Here I'm taking later date minus earlier date. But when I hit Enter, I get a duration. Now, I named that step subtract dates. We can, if we want to get actual days from that duration, duration has lots of amazing functions. We want Duration.Days, and it will extract the day part from that duration. And now we have an actual number representing number of days that we can use in math calculations. Now this is page 17 in our PDF notes, and there's 2 things that Power Query dates do beautifully. Now, the first thing is, well, the dates go from 12/31/9999 all the way back to 1/1/1. And the second thing, when they invented Lotus in Excel, they accidentally thought that January 1990 was a leap year. So they included 2/29. Well, that day does not exist. And look what Power Query did. All the days from 12/30/1899 and forward are 0, 1, 2, 3, and so on. All the ones before 12/30/1899 are negative numbers. And they just flat out skipped over 2/29. But look what they did. If you import these dates into Power Query, because the serial number for 2/29, a day that doesn't exist, is 60, well, it gets assigned to 2/28. But serial number 59, that's 2/28/1900, that correctly gets assigned to 2/27 because the two serial numbers are the same. And still further, the fact that all of these dates are negative, when you do a formula like end date minus start date, you always get the correct number of days. 12/99/1899 minus 12/28/1899 is -1 minus -2, which is 1 day. All right, let's go to the query dates and time and see something absolutely spectacular about M code and Power Query. Hey, we have start date and end date. These are serial numbers, but these are text values. Look, they're before 1/1/1900. Well, that's a long ways before. That's 1/1/1, and this is 1/15/1598. But all we have to do is select both columns, right-click, change type. I'm doing it this way so I can do both columns at the same time. And when I select the data type date, it's not going to do anything to the dates that already have a serial number, but those text values will be converted to date serial numbers. So when I click, that is absolutely magic. Now, this is spectacular, the year 1. Now I want to select start date, add column from date and time. And there's all sorts of amazing options for what you can do or get or extract from a date. All I want is year. And sure enough, there's the year 1, 1598, and 9998. And if you look up in the formula bar, just like duration functions, we have date functions. We have date.year, month, day of the week, and many more. Now, I want to add data types to the rest of these, but I don't want to add an extra step. So I'm going to go to Add Data Types. And this will just add them to the existing function up here. Drop down decimal. It's going to ask me if I want to insert, but it's not going to insert a new line. It's just reminding me if I insert a step, it might adversely affect steps that come after. I'm going to say insert. Let's convert these decimals to times. Right-click, down to change type. And we want to convert the value from a number to time. We select time, insert, and we have our times. Now I want to add days to the end date, so I select the last step. Add column, custom column. And we'll use the same function we used a few minutes ago, Date.AddDays. There's the end date, comma, days to add to end, close, OK. And sure enough, even though it's the year 1, we can still do date math with that date. Now I went ahead for new end date. In the Table.AddColumn function, I added the data type in the 4th argument. Now, the next calculation we want to make is we're going to assume that this is an employee clocking out, and this is an employee clocking in. So we need to calculate total hours worked. But the problem is some employees sign out after midnight. Now, earlier in the class in the Excel worksheet, we saw how to solve this using the mod function. But we don't have a mod function in M code. No problem. We will simulate what the mod function does. Let's add a column. Add column, custom column. Now we'll call it hours worked, and we'll build this step by step. End time minus start time. Click OK. Well, these durations here are correct, but these are totally off. Now the first thing we need to do is convert these to numbers. So we're going to click the gear icon. And there's a great function called Number.From. And this function converts any value if it can be converted to a number, to a number. So durations can be converted to numbers. When I click OK, we get decimals, and the first 3 are the correct decimals for a proportion of a 24-hour day. But these amounts are not correct. But if we add 1 to this, this would give us 0.32, and that's the correct hours worked. Add 1 to this, and we get approximately 0.27, the correct proportion for hours worked. But the trick is, how do we get a formula element to copy down and go 0, 0, 0, 1, 1? Well, what if we rounded these numbers down? Now we're going to use the round down function in M code, and round down would round all of these to 0 and these to -1. Now that would give us a -1, but if we subtract -1, that's the same as adding 1. Now don't confuse the round down that we're about to use with the Excel worksheet round down. If you use round down in the worksheet, all of these become 0 because that function goes towards 0. If you're in the Excel worksheet, the parallel function is the int function. Now back up in the dialog box, we're going to have to use this formula element 2 times. And anytime you have repeating formula elements, we can use the let expression. And if you remember back to last video, we used the let worksheet function in the same situation. In both cases, the worksheet function and let expression, the advantage is when we store this as a variable in let, it's calculated 1 time, and the value is stored in memory. Then it's used throughout the formula. That saves on calculation time. So right in this dialog box, we're going to use let space enter. And I'm going to call this end minus start. And guess what? This is the only variable that we're going to define. So no comma, enter. Now we type in, and everything that comes after in is going to be our formula. Now let's test our variable end minus start. Click OK. OK, nothing changed, which is good. Click the gear icon. And round down and all of the other rounding functions in M code always start with Number.Round open parentheses. By default, it rounds to the 1's position, which is exactly what we want. When we click OK, that is absolutely magic. So we have a formula element that copies down and gives us zeros, and then, -1. We really need to add 1. No problem. From the original decimal, we'll subtract -1. And -1 is the same as adding 1. End minus start. And we subtract. And here's the moment of truth. When I click OK, that is a thing of beauty. We get exactly the 2 correct proportions of a 24-hour day for the people who signed out after midnight. To finish this off, we'll just take the proportion of a 24-hour day and bump it back up to integers that represent hours. And there we go. That is an amazing formula. Now, as we'll see later in this video, once you get a formula like this created and you need to use it over and over, we'll actually create our own custom function. Now we have 2 more date value data type related problems to solve. We want to go over to ISO and French dates. Here are some French dates, some French numbers, and here are International Standard Organization dates. They come with year, month, and day. Now, it's easy to convert them using data types. But sometimes these ISO dates come as numbers. Other times they come as text. Now, if they're text, all we have to do is click the date data type, and bam, they're serial number dates. But we got them as numbers, so we first have to convert them to text. So we're going to come up to data types, text. It adds a new step. Now we come up and we want to add date. And it's going to ask us, do we want to replace? And we do not, because we need that text conversion there first. So we say add a new step. And just like that, from a number value to a text value to a serial number date value. Now, the last date-related value topic we need to talk about is, what do you do if you get dates that are in a different format than the control panel regional settings on your computer. The dates and decimal numbers we have are not being interpreted correctly. They're both considered text. Now we're going to use a feature called Using Locale, and it does require that you know where the data came from. Down here on the sheet Locale Codes, I listed all of Microsoft codes for where data comes from. You can look it up, and then you know which locale to select. Data types, using locale. I definitely want these as dates. And here's the long list. Probably a lot of you in the world that download the data that I put out there have to convert it from this option here. There it is. There's the one we want, French, France. When I click OK, now from text values, we have serial number date values. Same thing here. We want these as decimals. There it is. Click OK. And now we've converted the text values to decimal values. Now, when we did this, we had to do it in 2 steps because there wasn't a consistent data type we could add to both columns. But let's do a little M code cheating here. I'll select the last step. Notice what it does is it takes the column, lists the type. Oh, and that's a list within a list. And then there's the code for it came from French, France. So watch this. I know that the previous step used a list within a list. So the inference is, without even looking it up, is that I can copy and paste this into that other list within a list. So there's the first list, comma, Control V. And now I will click the check mark, and bam! Now I can delete this step. Now next, I want to look at the difference between the functions Duration.Day and Duration.TotalDays. Now we looked at Duration.Days, but I want to distinguish between this function and Duration.TotalDays. Now we have a duration 10 days, 12 hours, 15 minutes, no seconds. .day extracts just the hours. So when we enter, I get 10 days. However, if I use .TotalDays, it'll take all of the inputs from duration and give 10 plus whatever fraction of the day it is. So when I hit enter, that's 10.51. We also have an intrinsic function for date time, year, month, day, hour, minute, and second. So when I hit enter, looks like it's 10:10 a.m. on 5/5. Now there's also an intrinsic function for Datetimezone, and this allows us to offset backwards or forwards based on universal coordinated time. So I already have year, month, day, hour, minute, seconds, comma. The next argument is positive or negative, how many hours you want to jump. So I'm going to jump 8 hours forward, comma. This one's for minutes, 0, negative, or positive. I'm just going to put 0. This, from the base time when I hit enter, will add 8 hours. Now in the PDF notes on page 21, we got to talk about tables, records, and lists. And these are different values than any of the values we've studied so far, because all of these can hold multiple values. Now we're going to start with the list first, and we've already talked about it a little bit. When you hard code a list, you got to start with curly brackets. You put whatever elements you want, and they can be any of the other values, including other lists, and you separate them by comma. We also already saw the power of lists and lists within lists inside of functions. Now, this is a picture of the Table.Group function we created. And there's the name of the column we use to group inside a list. So the automatic feature created that. And once you see that, you know that you can have multiple items. And sure enough, when you're grouping, you can group by multiple columns. But the real power comes from a list within a list when, in the case of doing an aggregate calculation, we need 3 things. We need the name of the column, the type of aggregation, and what data type. So there's the list serving this purpose. 1, 2, 3 things all into one location. And because we have 2 aggregate calculations, we have 2 lists inside of the outer list. Now, the other thing lists do, and this is so amazing, you can type any start and end number and a ... and it will give you the whole list. You can also do this with letters. All right, let's create a new step, and we're actually going to create 3 lists. The first one, we'll just put some stuff in it. We have some text. How about a number? And a list within a list. When I click the check mark, there's our list. And that is what a list looks like. And later we'll see when we look up a column from a table, it's returned as a list. We can even click off to the side and see there's our sublist. All right, we want to create a new step and see if we can create a sequence of numbers from 43, and we'll use the dot operator all the way to 72. When I click the check mark, that is amazing. Let's do the same thing with the alphabet. Curly brackets, and whatever letter you start with, it's got to be in double quotes, dot, dot. I'll go all the way to Z. Click the check mark, and there we go, M to Z. If we go up to Date Type Sales Query and open up the formula bar, look at this, list.sum, list.standard deviation. Yes, all aggregate functions require a list before they can aggregate. To see this in action, I'm going to remove everything except for the reference to the sales column. Now with Table.Group, it groups related records into a table. For example, for Workday, it has a little table with all of the records. So when we use this field access operator and hit the check mark, it actually goes for each one of those little group tables. And our field access operator created a list of all the numbers. So in every single case, when you use any aggregate function, you have to extract a list first, and then put it inside the list.whatever aggregate calculation function, and bam, it does that aggregation. Now here's a great example of when we can use the list to solve a problem. This is an improper data set. The years 19 to 23 are listed in a single cell. They're really supposed to be listed in rows with the name repeated. Well, if instead of text, we had a list with all the numbers from 2019 to 2023, we would have an expand button up at the top. And we could expand to rows. All the numbers would be listed, and the word would be repeated. So let's, from the text, create a list. Add column, custom column. We're going to call the column year list. And we need to get from the start 4 characters, and then from the end 4 characters. And here we need 2022 to 2022. And because there's only 4 characters, it'll be both the start and the end. We can use text.start. This is the equivalent to the left function in the worksheet, and DAX. We want year, comma, 4 from the start, close parentheses. Now let's enter this and see what happens. Well, we got the correct year, except for there's an error. And the problem is that function right there can handle text, but not a number. No problem. Data types come to the rescue. I'm going to come over to data types, and we'll just add a step. We'll add text data type, insert. Well, it looks like text there. When we go back here, bam, that is working. Back up to the dialog box. Now this is text, and we do need it as a number. So we'll use number.from, and we'll check. Looking good. Now, because the only difference in the second part is end replacing start, I'm going to copy this, come to the beginning, curly bracket, dot, dot, Control V, close curly bracket. And then I'm going to double click start, type end, and that should do it. When I click OK, there is a list with the years, including this one, with a single item. What that means is when we expand, they'll just be 1/20/22 with lim. But up here, each one of these years will be associated with Sue. We click expand, expand to new rows, and the list came to the rescue. Now, of course, we can remove this and probably rename this also and add a whole number data type. Now, a record value contains column names and exactly 1 row of data. This is the syntax using these square brackets for creating a hard-coded record. Not only that, but the field names in records are allowed spaces. This is called a generalized identifier. Now on page 11 in our PDF notes, there's actually 3 situations where you can use a generalized identifier. As we were just looking at, you can definitely use a generalized identifier with spaces, without that pound, inside a record, inside the field access operator, and also there's a lookup operator, which we haven't looked at, but we'll look at later. And records are often used inside of functions like Csv.Documnet, square bracket, and then you enter things for each argument. And when we look up a row in a table, it returns a record value. And we'll get to see that when we study Code Lookup. Now, a table value, of course, is field names in the first row, records in subsequent rows, and hopefully data types on each column. Now, if you need to hard code a table, there's an intrinsic function, and there's 2 different options. The first one is usually the best. You define it as type table, and there it is. There's a record to define the field names and the data type, and then you enter your record. Now, usually we're not hard coding tables into Code because we're usually importing our tables of data and doing our transformations. But occasionally, like in a lookup situation, this can come to the rescue. And we'll actually get to see a custom function that uses a lookup table, and we'll hard code it in. Now, here's an example of hard coding a table. Pound table, you declare type table. Then in square brackets, you list the field name and the data type. Then put a comma, next field name, next data type. Then in a list within a list, there are the records. And this is what the table result is. Now, the next Code value we want to look at, well, it's binary. And binary just means, well, a text file, an Excel file, a picture file. Now, there's still one value left to study, the custom function. But before we do that, we got to learn about Code Lookup. Now, starting on page 24 in the PDF notes, I have a whole section on Code Lookup. The first thing we need to know is we need to remember that Power Query and Code are base 0. So for row number 1, we'd say, hey, we want row 0. Row number 2, we want row 1. Here's a comparison between the index function and how we do Row Index Lookup in Code. If you know the index function, well, here's a table. You put table, row number, column number. So the name of the table is product. Row number 2, there it is. Column number 3, there it is. And there's the intersecting value. That's what we would return. But in Code, you start with the table name, and then in curly brackets, you put the position. Since we want row 2, we put 1. Then in field access operators, we put the name of the column. And now it knows to go to the 3rd column, 2nd row, get the value, and return it as the price. Now, on page 27, here's a diagram that shows you both types of exact match lookup. Static, that's where we hard code the position for the row. Dynamic, this is where we give it a lookup value, and it finds the row position dynamically. The Code syntax for row index lookup, well, we put the table name followed by the row positional index operator. That's the curly brackets, and then we hard code the number inside. That's followed by the field access operator, square brackets, with the field name inside. When you hard code a number in, however, if the column is sorted, it almost certainly will not return the same value as it did the first time. The Code syntax for Key Match Lookup, well, we start with the table, followed by the row positional index operator, the curly brackets. But then inside the curly brackets, we use the lookup operator. Now notice there's square brackets, and these square brackets only serve as the lookup operator when they're inside the curly brackets. Then we list the field name equal to some lookup value. That construction with the curly brackets and square brackets dynamically looks up the row position. And if you sort it, it'll still find whatever the lookup value is. Now when you do Key Match Lookup, just like when you use XLOOKUP in the worksheet, you're looking something up over a unique list. Whereas with the XLOOKUP, when there are duplicates, it just gets the first one. With Key Match Lookup, if they're duplicates, you get an error. And then that's followed by the field access operator with a field name inside. All right, let's go see how these are done. We're going to start in the lookup example query. And here's a table, product ID, product supplier, and retail price. Now notice the name of this step is add data types, but what is it delivering? It's delivering a table. So we come up to f of x, and let's try to look up Aspen. So that's row 0, 1. So in curly brackets, we'll put a 1. And when you just have the positional index operator for either row index lookup or key match lookup, it returns the entire row. So when I hit enter, the row is extracted as a record. Now from the record, we want to look up whatever the product is there. So there's the field name. So we'll use our field access operator, product. And when I click the check mark, I've done a two-way lookup, row, column. Now we actually did two types of lookup already. We actually looked up just the record with just the positional index operator on one. Then we did a two-way lookup with the row and column. If we remove this positional index operator, now we're looking up from a table just a column. And remember, when we look up a column from a table, it is returned, enter, as a list. Now I'm going to go back and put the positional index operator in, click the check mark, and we've looked up Aspen. Now we hard coded this in, so if we sort the data set, it's always going to get what's in row 2. So if I add a step here, I want to sort ascending. It's asking me if I want to insert, and I definitely do. So click insert. And sure enough, there is a new step. And when I go down to our row index lookup, sure enough, it's no longer getting Aspen. It's just going to get whatever is in row 2. All right, let's try key match lookup. And remember, add data types is the full table. So I'm going to click f of x, double click, add, and I see it right there. Right now, if I enter this, I just get the table. Now let's try to get Aspen using key match lookup. Positional index operator, lookup operator, product, that's the name of the field. And remember, for field names, we can use generalized identifiers. That means if there's spaces, we don't have to put the pound in double quotes. However, that rule does not apply to the lookup value. So because we're looking up Aspen, which is text, we have to put it in double quotes. And right now, because we're only looking up the row position, when I enter this check mark, I get a record. Aspen from the product column. Click the check mark. And now we've done a two-way lookup using key match lookup. Let's change the sort. Come up here, and we'll change it to descending. It's going to change this one here, the existing one. So I click insert. Sure enough, when I come down to custom, no worries. I can sort it however I want, because key match lookup is always going to be finding the row with Aspen. We can change this to retail price and check mark. And now we've done a two-way key match lookup to get the price. Now here are the products that we have. As with all lookup formulas, if you give it a value that's not in the column, when I click check, it's polite. It says the key didn't match any rows in the table. Now let's see what happens when we try to look up gel booms and their duplicates from the supplier column. All right, we're going to try and look up the record for gel boomerangs. When I click the check mark, it's polite. It says the key matched more than one row in the table. Now on the sheet tables, we'll be working with these Excel tables when they're imported as queries later in this video. But watch what happens when we try and import this. Click in a single cell, data, get and transform from table range. And go back to the source step. And there it is, key match lookup. Now let's investigate and see what's going on here. There's this amazing function called Excel.CurrectWorkbook. We know that's the dynamic row lookup to get the table event 2. And then apparently that came from the content column. So I'm going to Control X and enter. And sure enough, this amazing function delivers every single Excel table from the current workbook. And it has a name column. Now the thing about names for Excel tables in the worksheet, they have to be unique. There are no duplicate Excel names in an Excel file. That means Key Match Lookup will work perfectly on the name column. So if we scroll down, we wanted this table. So if we were to type this out, Control V, sure enough, the table is in the content column. So when I click the check mark, bam, two-way lookup to look up a table. Now let's try this again because we want to learn something important about some of the functions like Excel.CurrectWorkbook, SQL.Database, and other functions. And when these functions return their table of objects, they add a primary key to it. And it does that because it knows this is a unique list. Same when we use SQL.Database, it's coming from a database where the names are always unique. So let's see what happens if we use a feature called Drill Down. I'm going to select this cell. I can see the preview. I see the name right there. Right-click and Drill Down. Now this is a navigation step, and it says it's going to wipe out all of the other steps. But actually, it'll remove this for a second, add some steps, and then re-add it at the end. So when I click Continue, here's the original source. And what did it do when I drill down? It did Key Match Lookup. When you drill down, you can have two types of automatic lookup. Key Match Lookup only happens on tables with primary keys, like from Excel.CurrectWorkbook or SQL.Database. And it does Row Index Lookup. If we come back over to Lookup Example, let's add a new step. We'll go get our table, add data types, and enter. What happens when I right-click, drill down on this table? Well, I get Row Index Lookup. And the reason why? There is no primary key on that table. Now, we almost never have to worry about primary keys. But just so you know, when you do drill down, when you see Row Index Lookup, you know there's no primary key. When you see Key Match Lookup, you know your table has a primary key from functions like SQL.Database or Excel.Workbook, or someone used the Remove Duplicates feature, which also adds a primary key. All right, as we learn more about M code, we'll be doing exact match lookup often, Key Match Lookup, or Row Index Lookup. Now I want to look at a common lookup situation. I want to pull Add Data Types down as a new step. There it is. Enter, and it returns the table. And what I'd like to do is average retail price. Well, that means we need to look up, using our field access operator, retail price. And the great thing about field access operator and lookup across field names is they're always a unique list. So it'll always get the correct field as long as I spell it right. When I click the check mark, sure enough, it returns the values as a list. And all aggregate functions require a list. So we use list.average. And there it is. Right in the argument, it says, hey, I need a list. Well, we have a list of numbers, so we're going to average them. Click the check mark, and there's the average. Now, we've talked about the two types of exact match lookup. But there's another type of exact match lookup. With this type of lookup, we're not getting a row position and a column position to extract a value from a table. But instead, if we go over to F-unit sales, we just need to look up the price based on the product ID from this lookup table. When you have a lookup situation like that, we're going to start in the fact table, and we use the merge feature. So we're going to merge queries. This is the left or top query. We need to connect the tables through keys. This is the foreign key. We go over to the lookup table, dProduct. Here is the primary key. If we were using XLOOKUP, the XLOOKUP would be here. We'd copy it down. If we had a relationship in the data model, this would be the many. This would be the one side. Now, there are different kinds of joins that we can use when we merge. Left outer means all from the first, matching from the second. That's just like XLOOKUP and a one-to-many relationship. We, of course, want all the rows here, but when we look up a price, we want to bring prices over only for matching product IDs. A right outer is the opposite. Normally, we just stick with left outer and switch the tables. A full outer is an OR logical test. That means everything from both tables. An inner is an AND logical test. You keep rows only when the lookup value is in both tables. And then left ante, that's when from the left table, you want items that are not in the right table. This is common when you say, hey, give me all the people in list 1 who are not in list 2. And again, we don't use right. Usually we just switch the tables and use left. All right, we're going to use left outer. Click OK. And it brings over the whole table, but we can use expand. We don't want all the columns. We want price and cost. Hey, look at this. We're looking up using exact match and pulling 2 items over at once. Click OK. And we've performed an exact match lookup based on product ID and returned cost and price. Now, if we go back to the previous step, we can see the function that performed the join. Table.NestedJoin. There's the table from the previous step. There's the foreign key from that table. There's the lookup table. There's the primary key. These 2 columns are what connected the 2 tables. That's the name of the new column. That's a default name. And there's the join kind. So the same function, table.NestedJoin, is used. And then you just change the join kind. Now let's try an inner join. We have event 1. Some people went to event 1. We have event 2. Some people went to that event. And we want a list of the people who went to both. So Sue Nolene. We can see Sue Nolene went to both, so we want that name. Cindy Warren went to event 2, but not event 1. So we don't want that name in the final list. So we'll select the query, merge. I want to merge as new. Top table, we'll select event. Event 2, event 2. And we want inner join, only matching rows from both. This is an AND logical test. Click OK. It brings in an extra table, but now we have what we want. Right-click, remove. And there are the people who went to both using an inner join. Now, if we go back to the source step, sure enough, there's table.NestedJoin, table 1, key 1, table 2, key 2. There's the name of new column, and there's joinKind.inner. Now, let's go back to event 1. Now we want a list of people who went to event 1, but who did not go to event 2. This is a left anti. So we go up to merge, new, event 1. Event 1, here's the column. Event 2. And we'll choose left anti, rows only in the first. Click OK. Same thing, we get this extra column, right-click, remove. And there's our list of people who went to event 1, but not event 2. If we go back to source, there's our table.NestedJoin, but this time it says joinKind.leftAnti. Now, the next topic is not exact match, but approximate match. But guess what? We have to study custom functions first, because there's no built-in way to do approximate match lookup. But we'll build a custom function. So our next topic, we're going to learn how to create custom functions. Now, page 32 in our PDF notes has some notes, but here's an all-in-one cheat sheet. If you wanted to create a function to add, the syntax is, hey, you open parentheses, and you can name your variables whatever you want. Then you use the goTo operator, equal, greater than, and everything after is the mapping of the variables. And this is the calculation that the function will make when you invoke it. Now notice here I named it x and y, but you could easily use num1, num2. And when you invoke this function, just like we saw in last video with lambda, these are the names of the argument. Now you can optionally define a data type. So num1 as number, num1 as number. And you can even declare a type for the function as number. Then you put the goTo and then whatever the calculation is. Here's a simple example. We say date as date, time as time, and the function delivers a date time. And then the goTo operator, and you join date and time to get date time. Then when you invoke this function, you just enter whatever the date and time is, and it creates the date time. Now back in the query dates and time, we already have the perfect candidate for a custom function. I do not want to have to type this out every time I'm determining time from an end and start time. So I'm just going to copy this, Control-C, click the check mark, go over to New Sources, Other, Blank. It shoots me up to the formula bar. But let's name this function first. Something like hours worked. We want to come up to Advanced Editor. I'm going to highlight all of this and delete. Enter. And we're going to build our function. So open parentheses, start time. And I'm going to define a type as time. And then comma, end time as time, close parentheses. And then this is going to deliver hours. And so we want it as decimal, which is number. And then we use the go-to operator, equal, greater than, enter, enter, Control V, tab. And this little parentheses right here, that red is saying, hey, watch out, this won't work if you enter it. That's actually from the Table.AddColumn function, so I'm going to backspace. That's all we need there. Then we take our new variable name, Control C, and we put it where we used to have a column reference, Control V. Now I'm going to copy end time. That's the new variable. That will be the name of this argument when we invoke it. Control V. Now what we've done here, open, close parentheses, these two variables, these will actually be the screen tips in the function. And when we invoke this function, it's going to say, hey, I need a start time, and we'll select a start time column. We'll put into this argument the end time column, and then whoop, start time will go to there, and end time will go to there. So when we enter the two arguments, they get put into this formula. The formula is calculated. And because we have these open and close parentheses, when we enter this, it'll recognize it as a function. Now I am going to put a note at the top. So forward, forward, something like calculates hours worked from start and end time, can handle night shift. When I click Done, over in the queries list, next to the query name, that f of x, that means Power Query recognizes this as a reusable custom function. Now this parameter thing, I never use this. But if you enter a start and end time, it'll actually create a brand new query with a single answer. But that's not what we want to do. We want to come back over to dates and time. This is so exciting. We want to add a column at the end. We go up to Add Column. And instead of Custom, we get to click Invoke Custom Function. New column name, hours worked. And then this has a drop-down with all the functions in this file, hours worked. And look at that, argument 1, 2. Now, we could just type this, but click the drop-down, and now we can select from a column. So I click the drop-down, and there's my start time. I don't want to enter a time. I want to have it look at a column. So I select end. And when I click OK, I get an error. Click to the right of the error. Well, that's polite. I did not program the function to give error messages that are actually easy to understand. But look at that. Instead of end time, I accidentally clicked on end date. And now when I click the check mark, that is a thing of beauty. I can use this over and over. Now, in the formula bar, you can see when we clicked Invoke Custom Function, it went ahead and used Table.AddColumn. There's the previous step. That's what we named it. And there's our beautiful function. We probably should come to the end and use the fourth argument, comma, type number for decimal. Click the check mark. And there's our decimal data type. Now, just so we're clear, in Advanced Editor, when we did open parentheses, close parentheses in that go to, that's the trigger inside of M code that says, hey, this is a function. When we define these two variables, they showed up in the Invoke Custom Function dialog box, 1, 2. And when we entered the two columns, wham, that went there. This one went there. And for each row in our table, it made this calculation. All right, that's function number 1. Let's go over to column of text and files. Now, this is the perfect time to talk about data source settings. That error right there, if we read it, data source not found, that's because this folder path is called an on-premise folder path. This also applies to on-premise file paths. And what that means is this is not an online source. This is a folder path connected to my computer. And it's saying, I can't find it here. And all of you will get this error because the path that I put in here is to my computer, not your computer. And that's what data source settings can do. We can redirect this folder path to the folder that you downloaded. So we click Data Source Settings. Select, Change Source, and there's the Browse button. We click. You navigate to wherever you downloaded your folder, and there it is. Double click. Now we're doing this for a folder, but you can do this for files too. Click Open. Click OK. Close. And then come up and refresh Preview. And now you've connected this query to the folder on your computer. Now here's the situation. Every week we get an import of text files. Here's a picture of it. And if we go and open up one of these text files, every single week I have to create a custom column that removes 1, 2, 3 rows and then promotes header. And not only that, but we have to use the Csv.Document function and tell it that this is a tab delimited file. So what we're going to do is we're going to go build it in our custom column like we do every week. Then once it's working, we'll copy and paste it as a function into a new blank query. And then bam, we have a custom function we can use every week. All right, in the query column of text files, let's go to Add Column, Custom Column. We're going to name the new column, and the content column has the files. We have to use Csv.Document function. Now, the Csv.Document function converts a text file that contains a specified delimiter into a table. Now, there's a bunch of notes here in the PDF notes, but the first argument is the source. So I'm going to double click, comma. The second argument allows you to tell the function how many columns to import. But if you hard code a number in and it changes later, that can be a problem. So you can skip it by putting null. Then it automatically just infers from the file how many columns there are. And then the delimiter. And you have to know the syntax for tab. I have quotes, pound, open parentheses, tab, close parentheses. And that's the M code for tab. Page 37 lists some of the common delimiters. Close. This is just the first part. Let's see what this gives us. Sure enough, it gives us a table, but headers are not promoted, and we have 1, 2, 3 extra rows in every table. So we can amend our formula and use table.skip to skip the first 3 rows, and then we'll use table.promoteHeaders to promote the headers. Now you can choose to go back up to the dialog box by clicking the gear icon, or you can edit up in the formula bar. I'm going to edit up in the formula bar. After each, I'm going to type a space, and then table.skip. I see it there, tab, open parentheses, and then delete, delete. And after the close parentheses for Csv.Document, comma, and we want to skip 3, close parentheses, click the check mark. And, well, that is looking much better. The last thing we need is we need to promote headers. So after each, space, table.promoteHeaders, there I see it, open parentheses. And I can just come to the end, close parentheses. And when I click the check mark, now we have a table in every single row. And so this will be our new custom function. It only has one argument, just whatever the column name is with the text files. I'm going to copy, click check mark, home. We'll open up a blank query. I called it weekly text files, whatever you want to call it. Advanced editor, delete all this. And open parentheses, we just have one argument, text file, as binary, close parentheses. And this is as table. go to enter, Control V. Then I just need the name of this new variable, that new function argument, Control C, and it goes in one place. It goes right there. And notice we didn't use in this time. We don't have to. Last time we definitely wanted it because we had repeating formula elements. There's our function. Click Done. There it is right there, f of x. Now we go back up and test it. Up to Add Column, invoke Custom Column. I named the column, and now we should have two functions. Weekly text files. It already is sensing that we probably want to pull from a column, and it already guesses right. So now I click OK. And that is so amazing. We built a function to clean up and transform that binary file into a table. Now that we have a column of tables, we want to append them. Now there's a few ways we can do this. One way is to right-click, remove other columns, and then use the Expand button. Click OK. That's fine. Notice it hard codes the field names in. That's probably fine in this case. But if that source column for some reason got updated and the field names changed, well, then that wouldn't work. Plus, I want to show you a one-step method instead of a two-step method. I want to delete until end. Yes, I want to delete all the steps to the end. We have a column here. I want to click f of x. And how do we extract a column from a table as a list? We use our field access operators. We type the name of the column, close square brackets. And when I hit Enter, I get a list of tables. We can see the table in each row. And that's perfect for our append because we can use the function, which is incorrectly named Table.Combine. It should be called Table.Append. And the argument says we need tables as a list. Well, that's what we have. Close parentheses and Enter. So in one step, we appended those tables. Add data types, highlight them all, transform, detect data types. Sure enough, I got each one correct. Now if I go back to invoke weekly text file, here's Table.AddColumn. And it uses the each keyword, as does other functions like Table.SelectRows. And we want to talk about the keyword each. Now let's go over to the query each and underscore, because we want to talk about each and underscore. They both do something amazing. Now let's just create a custom column and watch what the each keyword can do. Units and price, so go up to Add Column, Custom Column. We'll call this Sales. Units times price. And we click OK. We get total sales. And it's the each keyword that allows this formula to make a calculation in each row. The each keyword is a substitute for us having to build a custom function as a query, name it, and then invoke it in the column. Now let's look at underscore. I want to create a new column, custom column. And every time we use this, Table.AddColumn adds the each keyword to the third argument. We'll call this column record. And we're putting an underscore. We know that each will appear before it in the third argument. So when I click OK, sure enough, third argument, each and underscore. And here's one of the magic things that each and underscore can do together. Look at that. It extracted the entire record. So one thing to remember about underscore after each, it extracts everything from the row. In this case, it got the complete record. But it does something else also. Let's group, right-click, Group By. We're going to call it Table of Grouped Records, and we're going to select the last row. When you select this, it creates the table of grouped records in each row. So when I click OK, there's a table of grouped records for Quad, for Carlota. Now there's a bunch of stuff up here, and I don't want any of it. I'm going to delete everything. Backspace, backspace. We have to close off list within a list with double curly, and then close on Table.Group. Click the check mark. So now each and underscore giving us a table. That's correct. because it's inside of Table.Group. And behind the scenes in every row is a group table of records based on the unique list of product. So the way you can remember underscore used with each is it always gets everything in the row. Since it's in Table.Group, the row contains a table. Back here, there's no grouping, so the row contains a full record. Now, all of that is the backstop for understanding how and why each is a substitute for a custom function. Well, we know that we don't have to build our own custom function. We just use each. But let's go look at the definition that Microsoft gives to each. Here it is on page 33. The each keyword is syntactical shorthand for defining an unnamed custom function. Well, so far we do know that because we're not building a custom function and naming it. We're just using each. But then it goes on, taking a single untyped variable name underscore. Now, we saw what happens when we type it. It gives us everything in the row. But let's go see what they mean by untyped. All right, to appreciate what each and the untyped underscore is doing, let's create our own function. I'm going to define one variable. And whatever variable we put into open close parentheses, whatever we name it, it's always going to extract everything from the row. There's the goto. But in order to have the field access operator extract the value from the record, we would have to repeat the variable that we defined. So this will work. But that's a big hassle compared to not having to put the two variables and just each. And let's just check this out. I'm going to cut. It doesn't matter what variable we define. If we put just the variable, then it gets the record. And as we learned from our Code Lookup, if we want to extract something from a record, then we have to use our field access operator. Units, check. Well, it got the units times row square bracket price. And you can prove that this does not work if we don't put those there. This will help us see the unseen underscore in just a moment. If I go like this, that's just a flat out error. So the luxury of each is that it's a substitute for a custom function, and we don't have to put those underscores. Now, we could put those underscores there. Then they would be seen. And I click the check mark. Of course, it works. But Microsoft said, no. Let's just make it easy on everyone and just allow them to put each. Now, if that definition by Microsoft is confusing, just remember the practical uses for each and underscore. Each is a substitute for a custom function. When you use each and underscore on a regular table, you get a record. If you use each and underscore on a group table, well, it always gets everything in the row, so it gets a table. All right, now we want to put our knowledge of the each keyword and custom functions together and create another custom function for Approximate Match Lookup. Let's go over to fsales approximate. Now, the goal in this fact table is to create a column that goes and gets the discount based on a sales amount. Over here in ddiscount, it's got to find an approximate match here and then go over and get the discount. But of course, there's no built-in function to do this. Now, before we do this formula in Code, I want to jump over and try to create a worksheet formula that can better visually describe the logic of what we're going to have to do over here in Code. Now, the logic of the formula goes like this. I'm going to look at this sales value, and I'm going to say, how many sales values in this column are less than or equal to 774? True, true, false, false. We'll use that logical test to filter the table, so we'll only have these two rows. Then we'll look up the column, so we have these two. And then we'll use over in Code the list.last function to get the last discount. I'm going to create my formula here. Over here, we use the filter function. Over in Code, we're going to use table.selectRows. I'm going to filter discount, comma, and I want to include the discounts where the sales from that column are less than or equal to the sales in each row. let's just look and see what this gives us. Well, it gives us 2, just as we said a moment ago, F2. Over in M code, we're going to use list.last. But guess what? Here we can use take. Take says, hey, there's the array. And if you want comma, the last row, you put -1. And that's how the formula will work. I'll copy it down and up 1. And those are the values we'll get over in M code. Now, the first thing we have to do is add a custom column. We'll call it discount. And we actually need to pull the whole table over. So D discount, I see it there. Let's enter this and see what we get. And sure enough, we get the whole table in every row. Now, there is a performance problem with pulling another query. It has to pull the query over every time it wants to retrieve the discount table. So we can prevent that and store it in memory by adding a new line and buffering the table. So table.buffer, and all that means is it will retrieve it once, store it in memory, and will avoid the performance issue. I'm going to open the formula bar, and now we need to filter this table. Table.select, and there's a columns and rows. And just like filter, filter has array, we have a table. I'm going to get rid of that last parenthesis just for a moment, comma. Condition as function, well, that means we can use the each keyword. And from inside that table, we want the sales column. And then we want to say less than or equal to the sales column from this table right here. But there's a big problem with the each. And this is another important fact about each. That each works on this table. This one, it's working on that table. So if we put these columns here, both of the columns are going to come from that table. Now, we could define a custom function and define our own variable. But an easier way to deal with it is to, within the scope of this each, we use the let expression to define a variable. So let, and I'm going to use the variable sales equal to field access operator and sales. Because it's coming after this each, bam, that goes to that table right there. And because we've used let to define a variable in the scope of this each, in every row of that table, it will pick out the correct sales. Now we type in, and everything after in will be the formula. So all we did is let define a variable in in. All of this table.select rows is coming after in. And because the let defined it, stored it in memory, all we have to do is say sales. So when you have back-to-back each keywords, you can either define a whole new custom function here with your own variable, or just use the let expression to get whatever columns or elements you want from that table and define it as a variable. So that's the close on table.select rows, close on table.addColumn. And when I do the check mark, I click in the second row, and there's our filtered table. Now, since this is a table, we need to extract a column as a list. And what is delivering that whole table? Table.select rows. So we come to the end after table.select rows. And very carefully, we'll use our field access operator, table field access operator. So when I click the check mark, now we have a list in each row. Now we just have to use list.last. Before table.select rows, list.last. I see it's giving me that parentheses. Delete. And then I come to the end, close parentheses. And when I click check mark, bam, there's our approximate match lookup formula to deliver a discount. Now I copied and pasted the formula up here. And as an argument, I have lookup table as table. Notice it's inside of table.select rows. And then I defined lookup value as a number. And then in the first part of let, since this is the column that we're going to select as the lookup value, lookup column, there's the variable. And then I use lookup column right there. Let's click Done. Click on F Sales Approximate. add column, invoke custom function, discount to, we'll call it. And there's our third function. And notice it lets us select from all of the tables. There's our D discount. And then we want to switch this to column and select sales. When I click OK, now we have a reusable approximate match lookup for sales discount. And down here in new sales, I use the same function, but on a different sales table and a different discount table. And it's all working. As an alternative, if the discounts weren't going to change very often, we can just hard code the table right into the function. And this way, we don't have to worry about buffering either, because this is calculated once and used throughout the formula. And then when we invoke our function, we only have one column, the lookup value. All right, to close out this epic M code video, I want to talk about the Table.Group function. Now, we've already used this function a bunch, and we're familiar with the first three arguments. We need the table, and then the key. That's the column to extract the unique list from. And then list within a list, the aggregate calculations. But there's also the fourth and fifth arguments. There are some notes here, but let's go look at an example where we want to use the fourth argument. Here's a list of the Oakland A's with the dates and wins and losses. Right here, this is the fourth argument. If you leave it empty or put a 1, all it does is get a unique list. So we just have a list with win and loss, and then the count. But if instead of a 1 you put a 0, this is called a local group kind, then it does consecutive. So instead of grouping and getting a unique list, it's going to get busy looking for consecutive. So all of these wins will be grouped together with the count. That loss will sit by itself. So will those. This will be a group. This will be a group, and so on. Let's go see how to do this. Here's the A's consecutive streak query. Come up to Results, right-click Group, Advanced. We're going to call this one Wins and Losses. We'll add an aggregation. We'll call this Dates. And for the time being, we're going to get the min on the date column. Click OK. Well, we got our unique list, but let's change it. After the list within a list for aggregate, comma, and there it is, GroupKind. 0 means consecutive. Now, before I hit Enter, as I mentioned earlier in the video, that gear icon will go away because the fourth argument isn't in the dialog box. But we get exactly what we want, the consecutive streaks for the Oakland A's. Now, I'd like a range of dates from min to max. I'm going to need it as text. So I'm going to use the function text.from. We saw number.from, but this will convert it to text. Check mark. Now, watch this. I want min date to max date. So I'm going to copy this, and I'll just change that to min. And then use ampersand, double quotes, 2, with some spaces, ampersand, Control V, and we'll change in to x. Check mark. And bam, we have our report. We have our consecutive streaks, and we have the dates. The Table.Group fifth argument comparer allows us to use functions to create grouping categories. For example, we could group by equating letters from different alphabets. We could group case insensitive, or we can create our own custom function to determine the grouping categories. What we want to do in this example is go from this data set where we don't have consistent case, and we want to group to get this report. It's as simple as using one of the built-in functions. Here's our data set, and I've already grouped. So we'll come to the fourth argument, comma, Shift Enter. And I want to skip this argument, so I put null, comma, Shift Enter. And for our compare function, COM, I see it right there, tab. And that's all we need to do. Click the checkbox, and there's our report. Now here's our terrible data set. We have sales rep and sales in the same column instead of 2 columns. But what we're going to do is we're going to use the fifth argument of Table.Group and run a logical test that says, are you text? True, false, false, false. But the fifth argument in Table.Group does not accept trues and falses. So you always have to convert them to ones and zeros. This will be 1, all zeros. 1, all zeros. Then the function says, hey, wherever I see a 1, I'm going to group everything until I see the next one. And the function that you have to build in the Table.Group fifth argument has to have two arguments. This is the initial value to check, and this is the list of values to check. What we're going to do is build this function, and the row argument pulls out the table. Then we use our field access operator to get a list of these values. Then we simply say is text, and that will deliver true or false. And number.from will convert them to ones and zeros. All right, we're in the query group by data. And here's our starting data set. I've already grouped, and I grouped to show the table in each row. We're grouping by this column. If we look at the tables here, well, of course, there's only one Sue, so that's all you get. But notice there's two 25s here. Now, if they both belong to Sue, that would be OK. But if we look back here, well, 25 for Sue, 25 for Juniper. So that means we have to use the fourth argument to group consecutive. That will split this 25 here, and then there'll be another 25 under Juniper. So in the fourth argument, comma, Shift-Enter, 0. Let's see what that gives us. Check. And sure enough, there's the single 25 down here for Juniper and for Sue. Now we have to use the fifth argument, comma, Shift-Enter, compare function. We have to build a custom function, but there are parameters. This function in this argument must have two arguments. I'm going to call the initial value seed. We do not have an initial value. That would be something like a 0 for some calculations or a 0-length text string. But guess what? Even though we don't need this argument, you still have to put it in when you're in the fifth argument of Table.Group. I'm going to call this row, even though this is going to have the list of items to iterate across and run our logical test. But really, that argument will pull out the table, the group table from each row. So we'll get the table and then square brackets, the name of the column, sales rep. All that gives us right now is the column as a list. And then we run the logical test, is text. That gives us our trues and falses. But trues and falses don't work in Table.Group, so we're going to use number.from. All right, let's see what this gives us. Click the check mark. And wow, there it is. It worked. It grouped everything together, but we don't need the word at the top because our goal is to sum. And we're going to need it as a list, so we can use list.sum. So we'll extract the sales rep column here. Click the check mark. Now we have a list. Now we can skip the first one. We used this before. Actually, we use table.skip. We're going to use list.skip. And by default, it just skips the first one. So that's what we're going to do. Check mark. There are the numbers we can use to add. So now list.sum, and then somewhere at the end here, close parentheses, checkbox. And you got to be kidding me. From this data set where we had, in essence, two columns of data in one column, we got to group by sales rep and get total sales. Now that was an epic M code video. We got to learn the 3 places to edit M code. We learned that the heart and soul of M code are those amazing M code values. We studied in detail all 15 different M code values. We got to study data types and see how, yes, data types can change the underlying M code value, but because there's always a source step, we always have the original values. We definitely studied the amazing let expression. And of course, we will memorize this cheat sheet so we can use the let anytime we're building a query or anytime we need a variable inside a formula. We also saw that operators, well, there's a different set of operators for each M code value. And we studied them in great detail. Now, one of the more amazing things we discovered about M code is Lotus in Excel mistakenly had a day that didn't exist. And M code and the underlying serial numbers fixed that. Not only did it fix it, but if you import the incorrect dates, it corrects them for you. We studied M code lookup, row index lookup, and key match lookup. And it ends up that lookup is done everywhere in M code. We even studied the merge feature and joins. And we studied custom functions. And we saw examples of custom functions all over the place. All right, if you like that video, be sure to click that thumbs up and subscribe. And we'll see you next Dame video.